I had a conversation years ago with someone, and they asked me, Professor, is it impossible that there are flying saucers? Can you prove it's impossible? And I said, no, I can't prove it's impossible, but it's very unlikely. They responded, well, that's not scientific. If you can't prove it's impossible, how can you say it's unlikely? And that's where I want to start with you today, because that person had it exactly backwards. That conversation reveals a fundamental misunderstanding of how science actually works. You see, science is not about proving things impossible. Science is not about proving things possible either. Science is about saying what is more likely and what is less likely based on evidence. Let me explain this because it's crucial. The scientific method, the real way we think about the world, is this. We make a guess about how nature works. Then, and this is the important part, we compute what that guess would mean. We work out the consequences, and then we check those consequences against reality. We test them, we observe. And if what we predicted doesn't match what we see, then our guess is wrong. That's it. That's all there is to it. It doesn't matter how beautiful the guess is. It doesn't matter how famous the person who made the guess is. If it disagrees with observation, it's wrong. But here's what people often miss. If something hasn't been observed, that doesn't automatically make it wrong either. It just means we don't have evidence for it yet. So, when we talk about aliens, real, biological, intelligent aliens living somewhere out there in the universe, let me ask you something. Do I think they exist? Probably yes. The universe is unimaginably large. Billions and billions of galaxies, each with billions and billions of stars. The idea that we're the only planet in all of that where life emerged, that seems statistically unlikely to me. But again, that's just probability. That's not proof. But now we come to a very different question. Have they visited Earth? Have they come here? This is where I want to apply some thinking. Let me talk about distance for a moment, because distance is really the first wall we hit. The nearest star to us, not a planet around a star, just the star itself, is about 4 light years away. That means the light from that star takes 4 years to reach us. Now imagine trying to send a spaceship there. Even if you could travel at some incredible speed, let's say 1/10 the speed of light, which is vastly faster than anything we've ever built, it would take 40 years to get there. And here's what people don't fully appreciate. That's the nearest star, just the nearest one. To the most distant stars we can see, the light takes billions of years to reach us. These distances are so enormous that they become almost meaningless to us. We don't have the vocabulary for them, really. We say light year, but what does that actually mean to you? It means that in 1 year, traveling at the fastest speed in the universe, you still only go 1 light year. 1. Now, you might say, well, maybe they've developed some super advanced technology that lets them go faster than light. And here's where we run into physics. Real physics. Not magic, not super science, but the actual rules that govern how the universe works. The speed of light is not just some speed limit, like a highway speed limit. It's not that you're not allowed to go faster. It's built into the very structure of space and time. Einstein showed us this. You cannot travel faster than light. You cannot. It's not a matter of engineering. It's not, we just haven't figured it out yet. It's literally impossible because of the way reality works at the deepest level. But let's say, and I'm being generous here, let's say we just accept that maybe there's some loophole we don't understand. Maybe they found something. Let's just put that aside for a moment and think about energy. Do you know how much energy it would take to accelerate a spaceship to near light speeds? I mean, really accelerate it. Not gently, but actually accelerate it. It's almost unimaginable. The numbers become so large, they lose meaning. You're talking about converting enormous amounts of matter into pure energy. You'd need resources on a scale that would make even the most ambitious human project look like a child's game. And then there's another problem that people often don't think about. Heat. If you're traveling through space at these kinds of speeds, you're not traveling through a vacuum in the way you might imagine. Perfectly empty nothing. There's dust, there are particles, there's the cosmic microwave background radiation. When you travel at near light speeds, all of these things become extremely dangerous. The friction, the heat generated, it would be immense. You'd need shielding, cooling systems, protection. All of that adds mass. More mass means you need even more energy to move it. So you see, each problem compounds the others. But let's say, and I'm being extraordinarily generous now, let's say they somehow overcome all of that. They've got the energy, they've got the technology, they've launched their spaceship toward Earth. Now we need to think about time. The universe is old. Life on our planet has been around for billions of years. Humans, modern humans, have been around for maybe 300,000 years. Our technological civilization, the kind where we send radio signals and eventually rockets into space, has been around for maybe 200 years. 200 years. Now, what are the chances that an alien civilization, starting from scratch on some other planet, would arrive at the exact same moment in history that we happen to be here? Think about that. Of all the billions of years life has existed on Earth, think about the window of time where we're here and they're here at the same time. Feynman actually compared it to this. Imagine fireflies in a dark forest. Each firefly blinks on and off. The tragedy of the universe isn't that it's empty. It's that the party guests are arriving at different times. They're blinking, but they're not blinking when the same firefly is blinking. The lights pass in the night. There's also something about biology that we need to consider. If an alien civilization developed on some other planet, around a different star, in completely different conditions, different gravity, different radiation, different atmospheric composition, different chemistry, their biology might be radically different from ours. They would have evolved in isolation. Their biochemistry might be incompatible with ours. If they came here, could they even survive in our atmosphere? Could our diseases not kill them? Could they eat our food? Could they even breathe? And if they did manage to get here, if they solved all these problems, what would they want? What would their motivation be? Now, all of this is just physics and biology. This is just thinking carefully about what the constraints of reality tell us. None of this proves that visitation is impossible, but it tells us something important. It tells us that visitation would be so unlikely, so difficult, that we should require extraordinary evidence before we believe it. And here's what I find remarkable. We have no such evidence. Not one piece. Let me be specific about what I mean. In all of recorded human history, thousands of years of written records, hundreds of thousands of years of human existence, we have not found a single piece of alien hardware. We have not found a single artifact that is unmistakably of extraterrestrial origin. Not one. Now you might say, oh, but there are UFO reports. There are thousands of people who claim to have seen flying saucers. And it's true, there are many reports. And I don't think people are lying about what they saw. But let's think about what they saw. Some of these reports describe craft accelerating from rest to extreme speeds instantly. Now, if you accelerate anything, and I mean anything, at that kind of rate, the forces involved are absolutely enormous. We're talking about forces that would crush human bodies to paste. The G-forces alone would be lethal. Not just uncomfortable, but lethal. If whatever is in that craft is biological and it undergoes that acceleration, the occupants die. There's no getting around it. The physics just doesn't allow for it. And then there's something else these reports often mention. They describe craft moving through our atmosphere at these extreme speeds, without sound, without visible propulsion, sometimes without heat. Now, basic physics tells us that something moving through the atmosphere at supersonic speeds creates shock waves, tremendous shock waves. You hear a sonic boom, you see heat. The energy has to go somewhere. You can't violate conservation of energy. These reports describe things that are physically impossible given what we know about reality. What's much more likely, and I mean this without any disrespect to the observers, is that they saw something unusual, something they couldn't immediately identify, and their mind filled in the blanks. Our minds do this. We see an unusual aircraft or a weather balloon or a reflection or a natural phenomenon we're not familiar with, and we interpret it as something extraordinary. That's not irrational. That's how human perception works. We have expectations built into how we see the world. And when something doesn't match our expectations, we try to make sense of it. That's actually quite rational, but it's not evidence of alien visitation. You know what I always found remarkable? No one has ever produced a piece of alien technology. Not once. In all these decades of UFO reports, with all these alleged sightings, with all these people claiming to have seen alien spacecraft, not one person has ever produced a piece of hardware. Not a scrap of metal with unusual properties. Not a device that doesn't work by any known principle. Nothing. If I told you I had a perpetual motion machine, the first thing you'd ask is to see it, right? You'd want to examine it. You'd want to test it. You'd want other scientists to test it. That's where the evidence is. That's where we can actually learn something. But we don't have that. Instead, what we have is testimony. I saw something. I saw a light in the sky. I saw a craft. And testimony is interesting. It's worth taking seriously in some contexts. But it's not strong evidence for something as extraordinary as alien visitation. Testimony can be mistaken. Observations can be misinterpreted. Memories can be unreliable. We know these things about human perception and memory. And here's something else. We have no way to distinguish between an alien visiting us and a completely different explanation. If someone says they saw a flying saucer, there are dozens of alternative explanations that are much more likely. A misidentified aircraft, a weather balloon, a natural atmospheric phenomenon, a hallucination, a hoax, a misremembered dream. All of these explanations already exist. They happen. We know they happen. So instead of invoking something that would require revolutionary new physics and biology and navigation technology, something that would require solving problems that seem fundamental